All right, we are on to lesson 4. I'm going to divide up lesson 4 into two videos. Okay, lesson 4 is about solving equations. So we're taking it to that next step now. In the first 3 lessons, we learned how to simplify expressions. Okay, so if you notice all the questions that we had in our first 3 lessons, none of them had equal signs in them. They were expressions that we had to just simplify, in some cases multiply and then collect like terms, or in some cases we just collected like terms because there was no multiplication. Well, in this portion of the unit, you're going to start to see equal signs on all of our questions. And so what we're doing is solving algebraic equations. Okay, we're going to do that kind of in a very step-by-step approach. We're going to start with the easiest ones, and then by the time the second video comes along, by the last question of the second video, we will have put everything together and used all our skills to solve more complicated equations. All right, but for the sake of this part 1 here, we are just solving what's called one-step and two-step equations. Okay. Before we begin, let's look at what the meaning of equations is. All right. When we're solving equations, it means that you're trying to find out what number the variable represents in your equation. All right. All equations have an equal sign in the middle. This helps us tell us what it is equal to. So for example, I have 3 times x, or 3 times a number plus 4 has to equal 10. So we need to figure out what that 3 times a number is, that x value. Okay, that's our unknown. We need to solve for that. Well, you could, I suppose, do it by doing guess and check. But guess and check isn't going to get you very far as we proceed and do more difficult equations, because it's just going to get too complicated to try to guess and check. But for something simple like this, can you think of what number needs to be multiplied by 3? Okay, then add 4 to it, and it should equal 10. So what should x be to make the left side and the right side of that equation be equal to each other? Okay, so left side and right side has to be balanced here. It has to be balanced. The left side, you have to figure out what x value will make the left side equal to the right side. Hopefully you see that 3 times 2, so if x was 2 plus 4 would equal 10, right? Because 3 times 2 is 6. Okay? And 10 equals 10. So, that doesn't make any sense to say 10 equals 10. That's not really our final answer. I shouldn't put a box around it. That's just our check. You know how I said guess and check? Our guess was we plugged in a 2, and our check shows that we have left side equals right side. Our final answer is x should equal 2 to make that equation true. Okay, so we know that we can use guess and check, but it's not the most efficient way. It's not going to be the way that's going to, by the end of the second video, it's not going to help us at all, really. So we have to think of a more systematic approach. Okay? Well, what we really want to do is isolate, meaning get the variable or the letter all by itself. We do this by doing the opposite operation of what the equation tells us. And I'm going to go through a little balancing example where you're going to see how this makes sense. But for now, let's just look at what are some examples of opposite operations. Well, operations are plus, minus, multiply, and divide. The ones that we're going to deal with in this course anyways are only those 4. I know that there's more than that. Okay, there's square root, there's squaring. There's definitely more than that, but let's just stick to these right now. So examples of opposite operations. Well, addition is opposite to subtraction. Oops. And multiplication is opposite to division. Okay? So those are our opposite operations that we're going to be dealing with. And it's vice versa. Like the opposite of subtraction is addition and the opposite of division is multiplication. So it works vice versa either way. Here's the rules, okay? So here's how we're going to end up solving this. And as we go through our balancing example, I'm going to refer back to this. So that's why I put this first, okay? The two most important parts about solving for equations is, one, that we need to separate the variables and the constants. So the variables means the letters and the constants means just the numbers. We have to separate them with the equal sign. So they have to be on opposite sides of the equal sign, the numbers and the letters. Whatever you do to one side of the equation, you have to do to the other side. And our example below is going to really explain why this is. Okay? Let's start with adding and subtracting simple one-step equations that have adding and subtracting in it. Okay? Let's say, for example, you have a balance to explain what this equation means. X plus 3 equals 5. Let's let X represent this box. Okay, so this is X. So X plus 3 of the circles should equal, so imagine that this portion of the balance here, okay, this point is where our equal sign is 5. The reason why this balance really works is it shows how the left side has to balance with the right side for it to be a true equation. So what does X need to be in order to have this balance stay balanced? Okay, what does X need to be? Well, you can probably look at it and say that, oh, well, X should be 2, right? If X were 2, you would have 2 plus 3 on one side, and you'd have 5 on the other side. Both of them equal 5, okay? But let's think of a more, instead of guessing and check, let's think of a more productive, efficient approach that will help us even when things get more complicated. Because remember what rule number 1 was actually, before I go to that. Rule number 1 says we need to separate the variables and the constants. So separate the letters and the numbers with the equal sign. So let's move this plus 3. I don't want it on the same side as the letter. I want it on the other side with the other numbers, okay, or the number 5 in this case. All right, so I want to move that over. Well, the way you move it over, let's think of a balance. You would have to subtract 3 on this side, okay? You would subtract 3, but what would happen if you subtracted 3 there? This balance wouldn't be balanced anymore, right? It would fall, on the left side, it would fall down because the right side would be heavier, right? This side would be heavier. If you took away these 3 here, right, all of a sudden, the right side would push down, or the left side would be pushed down by the heavier right side. So that's where the second step comes into play. Whatever you do to one side of the equation, you have to do to the other side to keep things balanced. Okay, so if you subtract 3 on this side, you also have to subtract 3 on this side. Whatever you do to one side of the equal sign, you do to the other. Now, if I subtracted 3 here, and I subtracted 3 here, so I'll just kind of color them off, what are you left with? What are you left with? Right? Well, I subtracted 3 here, so that basically canceled these out. Plus 3 minus 3 is just 0. So what you're left with is X equals 5 subtract 3, or X equals 2. Just like I have here, and just let me erase, just to clean that up a little bit. I took away 3. What was I left with? 2. So this idea of getting letters and numbers separated from each other by the equal sign, that's always step 1. And then step 2 is remember that whatever you do to one side from on your balance, you have to do to the other side of your balance as well. Okay, and there's the diagram showing what I just showed you. So if you subtract 3 on the left, you've got to subtract 3 on the right. Well, let's do some examples. I have x minus 17. I want to get x by itself. I got to separate x, and I've got to move the minus 17 to the other side. So I've got to have the numbers and the letters separated by the equal sign, right? Okay. Well, how do I get rid of minus 17 here on the left? You would add 17. That would take away, that would basically just give you 0. And whatever you do to one side, okay, actually before we write that, whatever you do to one side, do to the other side. So you end up getting x equals 12 plus 17. X equals 29. And you can check your answer here. Okay, you can check your answer. If I plugged in 29 into this x, I would have 29 minus 17, which of course equals 12. Okay, so you can always check your answer at the end to see if left side equals right side, if you plug in your whatever you got for x into your equation. Let's do the next one. Okay, so I have minus 2, I have x minus 2. I have to separate the numbers and the letters. So I want to move this minus 2. I got to get that minus 2 to the other side. So I'm going to add 2. Okay, but to keep things balanced now, it's an equation, I need to also add 2 on this side. Subtract 2 plus 2 just equals 0. So you're left with x equals 4 plus 2. X equals 6. Okay, so you can always go back and check and plug in 6 for x. You would get 6 minus 2, which of course equals 4. Let's do one a little bit more challenging with some negatives. All right, so I've got to move. Again, I've got to separate x's and numbers. Now, there's nothing that says that I can't keep x's on the right. So far, always the x was on the left, right? X is on the left. I kept it always on the left. But there's nothing that says that it can't just stay on the right, like on the right side of your equal sign. It can stay on the right side. So I need to move over that minus 2 or that negative 2. Okay, move that over. And to do that, you're going to add 2. That's going to cancel those out on the right. But then we'll be unbalanced, so you have to add 2 to the left side as well. So you get negative 5 plus 2 equals x, because these would just cancel each other out. Use your calculator, and you should get negative 3. Negative 5 plus 2 is negative 3. Check your answer. If I were to plug in negative 3 for x here, I would have negative 2 plus negative 3, which equals negative 5. Okay, so that's adding and subtracting. I suggest you pause the video now and redo the questions that I just did until you get the hang of it. Okay. Well, what about if we have multiplying and dividing? Like, what if we have an equation like this? 2 times x plus 8. So this is different than above. In the questions above, I had 2 plus x equals, sorry, let me just fix that. That should be an equal sign. So in the question above, we looked at things that said 2 plus x equals 8. Well, now it's 2x. 2x just means 2 times x equals 8. So 2 times a number has to equal 8. Okay? Well, let's think. I know that most of us, or a lot of us, would just say, well, x must just be 4. I mean, 2 times 4 would equal 8. That's true. But as things get more complicated, Like, what if I did decimals and I did 3, let's say 3.2x equals 86.7, and you had to solve for x? Good luck trying to guess and check what x should be, right? So we need a systematic approach. We have to have a systematic approach as equations get more complicated. Okay, well, here's what you're going to do. Remember, step 1 is to separate the numbers from the letters. So right now, I don't want this 2 beside my x. Okay, I don't want this 2 beside my x. I want to move it to the other side. Well, how do I move it to the other side? Currently, it's 2 times x. Okay, what is the opposite of times? It's divide. Okay, so we are actually going to divide by 2, but that's going to leave this unbalanced. So whatever you do to the left, do to the right. Divide the right by 2. Lo and behold, what happens on the left actually? Like when you have 2 divided by 2, how does that just cancel each other out? Well, 2 divided by 2 is 1, right? Any number divided by itself is just 1. So what you're left with is 1x equals 8 divided by 2. Well, from the last few lessons, we know that 1x is just x equals 4. 8 divided by 2 is 4. So we've done addition and subtraction equations. Now we're doing multiplying and dividing equations. Okay? And there's our answer of 4, which we got above. Let's try some questions. Okay, I have 7 times x, or 7 times a number equals 14. I want to move the 7 out of here, over here. How do I do that? Divide it out, because the opposite of multiplication, it's 7 times x. Opposite is divide by 7, but whatever you do to one side, do to the other. 7 divided by 7 just equals 1x equals 14 divided by 7 is 2. I'm going to stop writing the 1x now. I'm going to just start writing it as x. So please make note of that. I think we've looked at that enough where we should hopefully get the idea that 1x is the same as x. Okay, next step. We have negative 5x equals 40. Negative 5x equals 40. So I've got to move this negative 5 because it's negative 5 times x. It's not negative 5 plus x equals 40, right? It's not that. That's where we would have to take the minus 5 and add 5 on this side, right? That is not what we're doing. We are not dealing with addition and subtraction here. A lot of people get confused because, oh, they see this negative sign, right? They see that it's a negative 5, but it's negative 5 times x. It's not negative 5 plus x. It's not negative 5 minus x. It's negative 5 times x. So the opposite of multiplication is divide by negative 5. Divide by the same number. Because negative 5 divided by negative 5 is just equal to 1, right? Any number divided by itself is equal to 1. So in your calculator, right, these will just cancel each other out, these negative 5s. Negative 5 divided by 5 is just positive 1x, or x. 40 divided by negative 5 is negative 8. You can always check your answer, right? Negative 5 times negative 8. So replace x with the negative 8. It should equal 40, and it does. Negative 5 times negative 8 does equal positive 40. Last example here, okay, before we get to two-step equations. Now we have division. We have x divided by 4. Okay, we have x divided by 4. So the opposite of division, we want to move this 4 over to this side. The opposite of division is multiplied by 4. Whatever you do to one side, do to the other. Well, when you multiply both sides by 4, you end up getting this. Right? I multiplied by 4 here. I ended up getting 4x divided by 4. Well, those just end up equaling 1. 4 divided by 4 just equals 1. So I can cancel those out. And x equals 12 times 4, which is 48. Okay. You don't have to show this step. Okay, so let me show you what I will be looking for. Okay. You do not have to show, here's what you need to show me for sure. Something like this would be worth, let's say, 1 or 2 marks. So all I'm looking for here is that you recognize it's divided by 4. So the opposite would be on the other side, 12 times 4. That's what I'm looking for. So as long as you write that step there, I'm good. So something like this, let's say, is worth 2 marks. And there you have it. Okay? But, you know, because I'm trying to explain it to you, I'm trying to show you that if you multiply both sides by 4, what you get on the left ends up being x times 4 is 4x divided by 4 equals 12 times 4. And these 4's, I'm just trying to show you that these 4's ends up canceling out with each other because 4 divided by 4 is just 1x or just x. Okay, so that's why, you know, I really want to try to show you where that comes from. All right, so I strongly suggest you pause the video at this point and you redo these 3 questions I just did. Make note of how because I know where we're going to have some problems, is right here, for example. You are going to want to, see how it says negative 5 times x? You're going to think, oh, the opposite of negative 5 is divide by positive 5. No. Okay? You still divide by negative 5. You still divide by negative 5. Okay? What you're asking yourself is, what is the opposite of multiplication? And it's just division. So you're going to take that number, negative 5, even if it's a negative, and just divide it out exactly the way it is. Don't change the sign, okay? A lot of students think that you have to divide by positive 5 here. You do not. You divide by the exact same number that's above so that you get 1. Okay? All right. Let's move on. Solving 2-step equations. Now that you can solve 1-step equations, it's time to put our skills together to solve 2-step equations. Okay, so the goal, of course, is still to get all the letters on one side and the numbers on the other side. But the question is now, what do you do first? I mean, let's look at these more. There's these questions that are more involved. What should you move over first? Should you first divide everything by 3 because it's 3 times x? Or should you first subtract 6 from each side? Okay? What number should you move over first? That is the question that students always have. And here's the order. Here's the rules for this language. And it works, okay? So this isn't just pulled out of a hat. Like, this is stuff that actually mathematically checks out. Always complete addition and subtraction items first. So in an equation, if you see any plus, so you see my x term. I'm not going to touch my x term until I move over any plus or minuses. That's what I'm going to move over first. Okay? When there is no more addition or subtraction left, then move over any numbers that are being multiplied or divided. So in this case, it's going to be my 3. So I'm going to move over my 3 at the very end. So the rule is always move over addition and subtraction first, and then move over any multiplication or division. So let's do this question here. I'm not going to touch my 3x yet. I'm simply going to say I want to move this plus 6 to the other side. So I subtract 6, keep it balanced, subtract 6 on both sides. This gets canceled out on this side. Plus 6 minus 6 is 0. And you get 3x equals 9 minus 6. 3 x equals 3. See what I did there? Let that soak in. Now my last step. Remember, I've got to get x by itself. You have to get the letters and the numbers separated. Okay? So, last step is move this 3 over by dividing it out. Because it's 3 times x, divide it out on both sides to keep the equation balanced. These will cross out on this side. 3 over 3 would just be 1x, or x, equals, what's 3 divided by 3? 1. Check your answer. Okay, you can always go back and check your answer. Watch how you check it. So check, do 3, so you got x to be 1. So instead of x, I'm going to replace it with 3 times 1 plus 6. It should equal 9. Does it equal 9? Sure does. Okay, so my equation is balanced if I plug in x equals 1. Everything checks out. Example 2. Okay, hopefully now you can see what's the first thing I need to bring over. It is not the 4. It is the plus 1. How do I bring plus 1 to this side? You subtract 1 from both sides. So subtract 1, subtract 1. These cancel out. You get 4x equals negative 7 minus 1. 4x equals negative 8. Don't forget to do this step, right? Like you can solve negative 7 minus 1. So do it. Like plug that into your calculator. Get negative 8, right? Clean this up a little bit. Now you can remove this 4. And how do you remove the 4? Because it's 4 times x, divide by 4 on both sides. That will give you 1x on the left, or x. Negative 8 divided by 4. Plug that into your calculator. Negative 2. Again, you can check your answer. Okay? Just plug in negative 2 for x. And then see if you end up getting left side equals right side. Okay? So I'll do this one last time here. I'll do 4 times negative 2. Right? Because it was 4 times x. Plus 1. 4 times negative 2 is negative 8 plus 1. Negative 8 plus 1 is negative 7. And look at this. Okay, it works. That means the number that I found was the correct number. X equals negative 2 was the correct number to keep this equation balanced. Last question. Last question. Again, what's the first thing you should bring over? The plus 1. Okay, bring that over first. It becomes minus 1. And actually, let me just show my work. I don't want to jump the gun here. I want to make sure that everybody understands. So subtract 1 on this side. Keep things balanced. Also subtract 1 on this side. That cancels these out. But I subtracted 1 on the other side, so everything stayed balanced. I get negative 4x equals negative 3 minus 1. Negative 4x equals, what's negative 3 minus 1? In your calculator, it is negative 4. Now the last step, get rid of this negative 4. How do you do that? Divide it out, because it's times x. So it's divided by negative 4 on both sides. Negative 4x divided by negative 4 is just positive 1x, or just x. Okay, so these cancel each other out. And negative 4 divided by negative 4 is positive 1 in your calculator. Once again, if you don't know if you got the right answer, you can sub in x equals 1 back into your equation and see if left side equals right side. Okay? I strongly suggest now, okay, before you start the homework, try these 3 questions on a sheet of paper on your own. Try to not look at my solutions. Try it 1 time, 5 times, 10 times, as many times as you need to do it to get the hang of it. I can't stress enough, learning algebra is like learning a new language, okay? If you don't practice it, it's just not going to sit in your head. The more you practice it, the more fluent you're going to get with this, okay? That concludes part 1 of 5.4. Part 2, we're going to look at some more complicated questions.